So I'm technically assuming that I'm live. So there will be a little bit of lag from my side for a few seconds, but after that I think it will be perfect. Okay. Because there's some connection issues that I'm facing like when I'm connected. I think now it's perfect. So if people have joined, so just write in the comment section, I mean write in the live chat that you guys have joined. Okay. That will be better for me to understand that, so that I will start with my video. Okay. In case there's something wrong with this video, just let me know, because I feel like not much people have joined right now. So I'll just do one thing. I'll just get to the Discord and just give the link, and after that I'll start with the video. Okay. So let me go to the first question first. So Discord, Leetcode. Okay, so let's do one thing. So let's start with the first question only. So first, the first question was kind of easy. Like it's a very basic, normal logicking. So if anyone has joined right now, or if anyone is watching this video, just give a just comment it down. Okay, just write in the live chat. So first, okay. So I'm assuming that like I'm perfectly visible, because from my end it's showing that I'm perfectly visible and I'm audible too. Okay. So this problem was very simple. You were given a date in the format of YYYY and what you have to do is you have to basically find, like, for every specific, for the year you have to convert it to binary, for month you have to convert it to binary, and for date you have to convert it to binary. So this was a very simple thing. So what over here, if you look at this, so it's basically 0 1, it gets converted to 1 in decimal, in binary. 0 1 is 1 in binary, and 1900 is basically this number in binary. So this problem was very simple. Like, if you look at the solution, I'll just show you the solution real quick. So my solution looks like this. This was a very simple thing. Okay, so I'm basically taking a year. You know that the first 4 letters are going to be the year, because it was given in that YYYYDD MMDD format. So since if it is Y, so if it is like in this format Y, so Y will be like 4 times, and then M will be 2 times, and then D will be 2 times, right? So basically for the first 4 letters I get Y, then from the 6th to 7th letter I get the M, and from 8th to 10th letter I get the D. Okay, so basically that is what I have done. So for the first 4 letters, then from 5 to 7, I mean 5 to 6 basically, and from 8 to 10. Okay, so I get the D, and then I just convert it to the binary string using the inbuilt function. After converting, I'm just appending it with that I dash. Okay, bro, can you just, why third was so hard to get accepted? Your third question didn't get accepted. I feel that the second question was like it was kind of, it took me a lot of time to solve the second question. So like I kind of fucked up this contest. Okay, so you can see that my rating is very bad in this contest. Okay, so I kind of fucked up this question, like, because of, you can see that there are 6 bugs over here. I don't know, like, okay, so it's showing that there are 6 incorrect attempts. So I feel that question number 2 was kind of not that good. Okay, not that simple. So I'm just assuming that question number 1 is like you guys have got question number 1, what it means. So I'll just move on to the second question quickly. So guys, whoever is joined right now, just give this video a thumbs up and like subscribe my channel if you're new. Okay, so so let's go to the second question. Okay, this is maximize score of numbers in ranges. So you're given an array integer start and an integer d, and what you can do is you can like put the value of AR of I in the range from start of I to start of I plus d. Okay, and you have to find this score, the maximum score, such that like the score means that is the absolute difference of the any two integers that can be chosen and the minimum absolute distance. Okay, so basically from here what you can get is like, let me write it. So basically it means just give me a second, so I'll just share my Discord and Insta code on like the live chat. Okay, just give me a second. Okay, okay, can you explain the fifth question of maximum number of moves? Do you mean the fourth question? Deepesh, do you mean the fourth question? Just tell me if you mean the fourth question or not. Okay, so anyways, so as I was talking about the second question. Okay, so basically you're given like you have, let's say you have got n numbers, okay, in the array. Okay, you've got n numbers in the array. Fourth, yeah, yes, I'll explain that. Okay, so that was basically, so I'll just give you a kind of spoiler. So that was basically some bit masking along with DFS. Okay, so first, oh yeah, yes, I'll explain. Okay, Deepesh. So now in this thing, so in this array what you can do is you can keep this thing in the range of s of I to s of I plus d. When I'm talking about s, I mean start. Okay, so now since we know that we can like have this range, we can fix this range. Just let me check my OBS. Okay, if I'm lagging or not. Okay, no, I'm not lagging. That's perfect. So basically if you have the like the freedom to like make the value as much as you can, so in that case you know one thing, that if I'm going to like I'm going to go for a greedy approach. But since it was given, so if you look at the constants in the question, it was given that the length of the start is of 10 to the power 5, the range is 10 to the power 5, and start of I is 10 to the power 9. So basically if whenever you know that whenever there is a 10 to the power 5 thing, so we can have a code back in our mind that the complexity should be big O n log n, right? It should be big O n log n. Now since it is big O n log n, so this n is going to give me the traversal. Okay, this n is going to give me the traversal. So basically I have to traverse throughout the whole array for every specific operation, and this log n is going to give me the binary search approach. Okay, the binary search approach. Now what is the binary search approach? The binary search approach is, let's say you have a value. Okay, now you know that the values of that specific interval, so you can go for some like pre-calculations done, but I'll prefer that you choose the best Uh-huh. Guys, if I am lagging by any chance, just let me. I'll explain. Now you know that the values. Okay, so if I'm lagging anyway, so you'll just write in the live chat, okay? Because I'm like, since I'm focusing much on the video, so I won't be able to tell you whether I'm lagging or not. Okay. So now, first of all, in the outer loop, you have to get the binary search, and in the inner loop, you have to find like whatever value you're getting, is that value satisfying the traversal for n or not? You get it? Okay. Thank you, man. Hello, Soumya. How you doing? Soumya, did you give today's Leetcode contest? So now, since we have the freedom to like make this value as like in this range, so what we have to do is finally, first of all, we have to find by binary search the value of mid. You know, like in binary search is basically L, R and mid, right? L, R and mid. So you have to find the value of mid, and whatever is the value of mid, you have to find that whether there is a minimum difference. It is possible to make a minimum difference of mid between all the elements or not. Okay, so that whether the minimum difference is mid or not. So if the minimum difference is mid, solve 3 out of 4, फोर्थ नहीं हुआ बिल्कुल भी, सेकंड सॉल्व कर लिया, बट जुगाड़ से प्रॉपर सोल्यूशन समझना was easy. Third was easy. So I'm explaining the second question right now, Soumya. So just focus on that. So basically, whenever you're getting a mid, so from that mid, what you can do is you can find that whether it is going to be the minimum possible or not, right? So now, if you look into my solution, I think I'll prefer you like if you can stalk me out. So just look at the wrong solutions also, okay? So you'll know like what made it accepted, because sometimes you need to get through the wrong solutions also. Okay. So let me just move on over here so that the screen will be perfectly visible for you guys. So this is normal. Now this is the function which is going to check if it is possible to select the integers or not. Okay, with at least minimum difference between them. So what is the minimum difference? So first of all, let me explain you this thing. Okay, can select integers. So over here we are getting the array start. Give submission link. Okay, yeah, I'll give it. Okay, I'll give it. You don't have to worry about that. I'll give it in the description, I guess. Okay, I'll give it in the description or maybe in the comment section. So like whatever it is, whatever will be comfortable for me, I'll just give it. So these two conditions, it was given in a main array also. Okay, and we are also given like the value of n, because like you don't have to compute the value of n again, and the minimum difference, which is the mid. Okay, the mid that I was talking about. Now what is the mid? So it will be better if we go to the last part of the code. Okay, I think this much only will be visible for you guys. So basically this is n is the start of size, and then I'm sorting this. Okay, why I'm sorting it? Because let's say if the difference has to be, the minimum difference has to be the same, like, or let's say it has to be maximized or something like that. So obviously the minimum difference is going to be, if it is sorted, so it is going to be the difference between the consecutive two elements after sorting it, right? Because if there is an element which is over here but it is greater than this as well as greater than this, so the difference of these two elements will not be the optimal thing. The optimal thing will be the difference of these two elements or the difference of these two elements, right? So for our better understanding of, and for better like simplification of the code, so we'll just sort it out first of all, the start thing. Okay, then we are performing the binary search on the minimum difference. Now we know like low is equal to 0 and high is equal to 2 into 10 to the power 9. Why is it so? So if you look at the condition, okay, so I won't get back to the condition back again, because that will like I have to go on to the solution back again. So it was given that the condition, that is the value of start. Okay, the value of start of I, it was in the range of 10 to the power 9, right? And D was also of the same range. Okay, it was also 10 to the power 9. Now, if both of them are 10 to the power 9, so it may happen that the last element after sorting, so the maximum possible value of the last element after sorting is this, right? 10 to the power 9. And it may happen that you have to add the d to it, because that is the range, that is the maximum range. So if you're adding these two, so it becomes 2 into 10 to the power 9, right? 2 into the 10 to the power 9. Now the value that I've taken, it is also 2 into 10 to the power 9, but just for a safety I'm adding 1 to it, okay? So just for safety reasons. And low is also 0, but that is also for a safety. We could have also gone for 1. It won't make any difference. Or like low can be 0 actually, sorry, low won't be 1, okay, low can be 0. So let's say now we have the answer. So this is the answer that we are going to compute, right? So this is normal binary search. You go for while low is lesser than equal to high, then make the mid as high plus low by 2. This is basically a like non-overflow condition of making high plus low by 2 or low plus high by 2 as you may call it. Then you have to check if you can select integers star d n mid. Okay, so mid is a valid answer. So you can check the this thing over here. So mid is a valid answer only if this situation satisfies. And if this situation satisfies, so let's say we have got the mid. Okay, we have got the mid. Took high as start n minus 1 minus plus. See, I know like if you ask me what should be the best value of high, the best value of high will be this. Okay, the best value of high will be st of n minus 1, whatever you have done. Okay, n minus 1 minus st of 0. Like I can even prove it. Why is it going to be the best? And after that, what you can do is you can make it n minus 1. And if you want to have a safety measure, you can add plus d to it. Okay, so whatever you have done over here, this thing will be a better, like this thing will be lesser than that. Okay, always. And this will be a better approach. Why is it so? Because if you're talking about the optimal thing, okay, optimal thing, the difference will be like evenly distributed. So if we are going to distribute the whole this whole thing evenly, so you can even go for minus also, okay, plus minus also. Minus is going to give you a better approach, but I haven't checked it. But plus d is going to be safely a good approach for you. Why is it so? Because if you're like, yeah, as I was telling you, so if you're talking about the differences between any two consecutive elements, so the best approach will be to divide the whole thing. So this is, let's say x, and this will be x plus d. Okay, this will be x plus 2d, and so on. And the last element will be x plus n minus 1 into d, right? So from here you can find the value of d. So the value of d is basically going to be like if you take this value and then this value, then subtracted and then divided by n minus 1. So basically that is what you get. Wouldn't matter in interviews to take most optimal values. See, if you're like doing an interview question, if the interviewer may ask you that, can you optimize it? Okay, so the interviewer won't like look into the fact that whether you're optimizing it at the beginning or not. So at the beginning, you will just give your approach. Okay, and after that, if the interviewer tells you that whether can you optimize it more or not, so then you can go for the like mathematical approach. But in most cases, like this, since it is log of 2, log of n, so taking a bigger value won't be of much concern for you, which I feel. Okay. But and the interview, if the interview is asking you that whether you can optimize it or not, so this value, yeah, you can go for it. Like you can tell the interviewer that yeah, I can optimize it by using this mathematical formula. But sometimes it's better that whenever the interviewer is telling you to optimize it, so he's basically concerned more about the time complexity. Okay, so that is like if your code is in big O n squared, can you make it in big O n log n or not? Something like that. Okay. Like obviously for this code, we could have gone for big O n squared. Okay, instead of going for the binary search, we could have gone from 0 to high, and for every specific element, we could have checked that whether this is possible or not, and then give the answer. That is also a possible thing. So basically, if you do that, so the interview will ask you that whether you can optimize it or not. So if you go for this approach, this will be fine. So now this happens that if we can select this integers, then we are going to make this answer as mid, and the low becomes mid plus 1, because if it is possible that if it's possible with this low values, so we can risk it to a bigger value. Okay, we can risk it to a bigger value, but if it is already a bigger value, which means that mid is already too large, okay, then you have to try for a smaller value. So this is normal binary search. So now I'll just go to the can select integers thing. So initially previous selected is start 0, that is the element that is selected just before it, because remember one thing, whenever we are going to look for this, like whenever we're going to look for whether you can modify it or not, so basically all the elements are consecutive, right? We could have gone for something else also. We could have gone for like start of I minus 1 in this cases for the previous selected, but I'll let you know why I went for start of 0, because you'll need to go through the code once. Okay, now long end next minimum is equal to previous selected plus minimum difference. So what is the next minimum difference? So let's say you have a value of x over here and you have a value of, let's say, y over here. Okay, y over here. So if I want to make this a valid thing, so this y has to be lesser than equal to mid, x plus mid, right? You may feel that y should be lesser than x plus mid, right? But the condition is a kind of different. That is, this will be only possible if we are going to modify the x, modify the y. Okay, but over here we are focusing on modifying the x. Okay, so you can go for modifying the y, but I think it will be giving you some kind of error at a very later stage. So it is better if you modify the previous element, because you are not concerned about that, right? Because whenever you are traversed throughout a specific array till n positions, let's say you have traversed till over here, and you have the opportunity to modify only this. Okay, if you have the opportunity to modify only this, it is better that if you modify this and like give this opportunity when you go to the next element. Okay, so that's what my approach is basically. So what I do is, so I'm going to find like what is the next minimum value that it can have. So basically we know that to keep the difference of minimum difference, so I'll just add that minimum difference to the previous selected element, and then I have to check whether the next minimum element, if this is greater than star I plus d or not, because this is the maximum range that is possible. Okay, so if it is greater, so as I was telling you this condition, okay, if it is greater, so I was telling you about lesser than equal to, right? So if it is lesser than equal to, then it's a proper thing, but if it is greater, we can say that it's not a proper thing. Okay, as I was telling you in the question, so if it is greater, we can directly return that it's a false. And if it is not so, now we are going to make the previous selected as whichever is maximum, the next min or the start of I. The present position is maximum, or the next minimum that is adding plus d to it is maximum or not. Okay, so based on that we can find the previous selected, like we can find the closest value, and then if at any position we are not facing any false, so you'll just return true. So that's it, how we are doing it. Okay, I hope you have got it. So people who are watching this, just let me know if you have got it or not. I can see that there are a lot of people watching this, so just let me know if you get it or not. Now you know that the values isn't any false. Right. Thanks, man. So I'll just go to the third question, I guess. Clear. Okay. So this is the third question. Okay, I think this got accepted. Yeah, this is the accepted code. Okay, so this was very easy. So first of all, let me do one thing. I'll just copy the code so that I won't have to like go to the description. So let's just go to the description first. Okay, so it is given that you have to reach the end of the array with maximum score. Okay, So you're given an array integers, an integer array nums with a length of n, and your goal is to start at the index 0 and reach till index n minus 1, and you can jump only to indices which are greater than your current index. Okay, and basically the calculation is going to be j minus I into nums of I. Okay, so if you I think it will better if you visually see this. Okay, if you visually get the how we are doing it. So if you look for the visual thing, so let's say we have some elements. Okay, now for the specific elements, so let's say over here it is x. Let's not go with x. So it is a, this is b, this is c, this is d, this is e. So if we are jumping from here to here, you can notice one thing, that what we are doing is the sum, the answer. So what was it? Was it the sum or the total score? Okay. Initially thought DP, but constant suggested greedy. Which one? This one? Soumya, are you talking about the third one or the second one? So if you're going for this, okay. Yeah, I think you're talking about the third one only. Yeah, it was greedy. So if you're going to this situation, to this position, so the specific sum is going to be, the score. So let me write the score only. The score, it is going to be a into 2, right? Because it is 0, this is 1. The positions. Okay, these are the positions of the thing, of the elements. Okay, so this is 4, 3, and this is 4. So if you're jumping to over here, so it is going to be a into 2. Now let's say, in order to reach over here, we could have gone for this, or we could have jumped to here and then jumped back to here, right? So if we did this, so the score would have been a into 1 plus b into 1, and it was given that you have to maximize the score. Now since you have to maximize the score, so you have to find whichever is going to give you the maximum value. From here, if we talk about whichever is going to give us a maximum value, so we can go for an approach that if okay, I feel like there are lesser viewers right now. Guys, please try join and share with everyone so that everyone joins. Okay, so anyone whoever is new to this channel, just give a subscribe, just hit the like if you like the explanation, and just write in the live chat that you are enjoying it. Okay, so basically if we have to find, it may happen that this value is greater than this, or the opposite, that this value is greater than this. Okay, or the opposite, that this value is greater than this. Now if we consider the first condition, that this value is greater than this, so we know that 2 of a is greater than a plus b, which means a is greater than b, right? A is greater than b. Now if we now you have to go for some visualization. Okay, so what do I mean by visualization? Basically, whenever you're going till c, you can either go for the sum of all the elements before that, or you can go for sum of all elements before that, taking something into consideration that this b can be either written as b or written as the element from which it has jumped, that is a. Okay, now if we jump from a to d, so basically what happens is this b becomes a, this c becomes also a. Why is it so? Because a to d gives us a sum of 3 into a, right? So basically if we are taking a jump, it means that we have to find the sum of all the elements, and we can just take off, replace the elements which are between that jump with the element from which we are jumping. You get it? I think that this is clear, right? So basically if you're jumping from one element to another element, it was given that you can only jump to indices greater than your current index, right? So this is a very good approach that we have given. So so we know one thing, that at the last position, when you come to the last position, you're not going to consider it, because let's say you have jumped from some position to over here, so this position won't be considered. So you can just remove this condition out, like I mean remove this position. Okay, apart from the all positions, it is always better if b is lesser than a, it is always better to jump over it. So basically for every specific value, okay, for every specific index or value as you may call it, you can either jump over it or jump to it. Okay, so let's say you have like this, and this is the index over here, so you can either jump over it or jump to it. Now if you are jumping to it, so these values are going to be, let's say this is a and this is b, so these values are going to be a and these values, they are going to be b. But if you jump over it, so all the values are going to be a, right? All the values are going to be a. Now when will you choose to jump to this position? You will only choose to jump to this position if this b, it is greater than a, so that it is going to give you a better solution, since you're going to take the sum, right? So if this b, I mean this element is greater than this element from where I am jumping, then only I am going to take it. Now let's say we have, now if we like go into this and just divide this problem into sub parts, so I am going to choose the first element that is greater than this element. Then from that specific element, I am going to choose the first element which is greater than this element. Okay, and we go on doing it until we reach the last element, and we are not going to take the last element. We know that, right? So let's go with the code. Okay, so I'll just go with the code. Jump only if greater. Perfect. Why can't I see my code? Yeah, this is my thing. I'll get back to the classic mode. Okay, so check this out. Okay, very simple code. The code is very simple. So you got the vector nums, and this n is the size of nums, and answer is basically the score. Okay, this answer is basically the score, and this m is going to give you the maximum. Like as I told you, like we are only going to jump if that is greater or not. So basically it is obviously better for us to take the maximum value that we have encountered till that position and give that position that value, right? Because let's say over here there is a position over here, so what is it going to be? This is going to be the value of this, right? And what is this? This is going to be the maximum value that I have got till this position, right? So basically we are doing that only. So I'm going for answer. So remember one thing, this is a edge case, that if n is like equal to 1, if n is equal to 1, you know that the answer is going to be 0. So we can directly return 0, but over here I'm just taking answer is equal to this, but you can directly return 0 for this. And if n is not equal to 1, then only you know that you have to consider the first element, right? Because you don't have to consider the last element, and if n is equal to 1, the last and the first element are same, so in that case you don't have to consider that, right? But if n is not equal to 1, then you have to consider it. So answer is this, and the maximum till that position is also going to be the first element. Now we traverse from the next element till n minus 1. We don't traverse till n. Why is it so? Because as I told you, the last element will be ignored, because you are jumping to that position, so you won't consider that. And then I take out the like maximum of everything, and then I just add it to the answer. So I hope this is clear for you guys. So just write clear so that I'll like understand this problem is clear for you guys. Oof. I haven't done the fourth question like because of the time, but I came up with an approach. So I'll just go for some editorials. Okay. So I'll just wait till like clear question 4 now. Yeah. See question 4. Okay, so this guy I know this approach. Okay, this masking and DP, or more like masking and DFS. BFS and DFS. I don't know about this approach. What he has done. So I know about this approach of like masking and DFS. Yeah, this is also the same thing, DP and BFS. Okay, I know kind of this approach, but for now, like I'm seeing that, so I'll just go for the most votes. Okay, whichever has got the most votes. So he's using bitmask DP, and then this check all permutations by using bitmask. Yeah, this I think this will be better for me to understand, but I'll still go for this. Who posted on LinkedIn about solving all four? Pre-compute number of steps required to go from position of each pawn and start. Okay, so first, okay, so it will be better. Like I forgot to like explain you the question only. So you're given a chessboard of 50 into 50 squares, and in one of the position there is a knight, and you're given like two integers kx and ky, which is telling us what is the position of the knight. Okay, and there are 2D arrays position where position is xi and yi. So basically there are pawns over there, and if you're going to consider the pawns, so let's say they are the crosses. Okay, so they are the positions that the knight has to visit, and so there are a few number of steps. So basically the knight visits one of the positions, and then the knight visits some other position till it has visited all the positions that has been given in the that thing or not. Okay, but remember one thing, if we select a position and while going to that position, if the knight passes through a position which is also there, it could per but solve with proper explanation, comments included in answer. Chat GPT use कर लिया. See, I won't say that this was like kind of like difficult, but this like like whenever you're giving a contest, so like the fourth question, the last question, even if it is easy, so it becomes difficult for us because we are like left with a very less amount of time, है ना? So that's the reason why like most people can't do the last question. And this was a good question. Like if I will say that I have not done it, but this was a good question. And a good question, I mean like good rated question. So basically, let's say, so first let me just give you a visual thing of the chessboard. Okay, so how many of you play chess over here? I think I was thinking of doing live stream on chess also, because I haven't been playing chess for a long time, but still we can go for some live stream, है ना? So let's say we have a chessboard over here. चलो चीटिंग तक ठीक है, बट फिर लिंक्डइन. सौम्य एक बात बताए तुमको, डीपी प्लस बिटमास्क का प्लेलिस्ट है क्या कोई बिगिनर फ्रेंडली? You're 1 to 5 elo in chess. That's good, man. I don't know how much I am rated. I think I'm rated below 1k. I'm rated below 1k, and that too I have not been playing chess for a long time. Okay, chalo. So if you have a pawn, so let me also go for these squares. Okay, so let's say whenever you're talking about the position of the pawns, so we can mark them as x. Okay, we can mark them as x. Now let's say we have a knight over here. So if you want to go to a position like this X, approach will be the best approach will be this only. I mean, sorry, this directly. Okay, you can go directly to this position, right? Well, that's the best approach. But if you like think of something else, like let's say for this position, and you're at this position, so the best approach will be like you go over, you go from this position to this, and I mean from to this, and then from this position you go to this. So it is going to take me 2 steps. And if I'm over here and I want to go over here, so it is going to be like dude, now I am confused of what to do. Is it possible to go over there? I think the knight is okay. So whatever it is, like I can't stress out my brain right now because we are doing Leetcode, right? So we don't have to like focus on much on chess. Okay, so let's get into the discuss session. So this is the solution that I was talking about. So what he does is he is telling us that we can pre-compute the number of steps required to go from position and each pawn and starting position to all the other pawns. Okay. So store the number of steps in the distance matrix of size n plus 1 into n plus 1. So basically for every specific pawns, now since they have like n pawns, so from n plus 1 to n plus 1, so from every pawn, so we can visit another pawn, right? And whatever is the initial position of that knight, so we can go till that pawn position. So that is I am just hoping that that is what he meant. Okay, so now we do a recursive. Okay, so it was recursive. Dude, I thought recursive will just make the time complicated. So I think I missed this question, man. So positions we are currently at, so there are 16 possibilities. Why is it so? 0 will be the starting position and 15 position of pawns. Was it given that the pawns of 15? I did not even like look into the. Okay, so it was given that it's going to be 15, man. Okay, doesn't matter. So what Alice does is Alice makes the turn maximum, the sum of the term maximum, and Bob does is he makes the term of the sum minimum. Okay, of the pawns, and then Bob does it that he can go also to the position of pawns, right? So first let us go to the main part of the code, that is this part. Okay, maximum moves. So he's initially making the set, so he's mem set. I think this is he's just doing what is it called, and I can't even think of it. Memoization. Sometimes that's short of logics. So he's taking a size of the DP and taking all the mem set to -1. Now he's creating a new array with starting position included. So he's basically including the starting position of the knight to that. And we know one thing, that the position of the knight, it is going to be like, let's say if we go for some making DP table for memoization. Yeah, exactly. I was like I was less of words, man. I lost my words actually. So if he is over here, so he can like take out the order. He can go for the recursive function to take out the order. So initially he is over here, then he can go to here, then here, then here. Or if he is over here, he can go to here, 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 right? So this is what he has done. So for every possible condition, I think he has checked it. Now map to keep track of the index of each position. So he is keeping a map so that he knows that this position is visited. I think that is what he is taking, like, I think that is what he is considering. Okay. Now since it is 1 best indexing, so he is just making it -1 to make it 0 best indexing, because you know in computer science we don't consider 1 best indexing as like right away. So now for every position, what he is doing is he is pushing that position to the array. Okay. And he is also making the map of that position I+1. That is the position he is visiting for the next time. Okay, so now what his position of what his array looks like is basically his array. So let me write it in red. So his array will somewhat look like the position of knight and the position of n pawns, right? This is what his array looks like right now. Clear? Now from this array what he can do is, yeah, I changed the channel name. How you, man, by the way? So basically, like, whenever you're going, okay, so let's say n is equal to the size of the array, which is, I think it is going to be n plus 1 only, because he made it like that, but it could have been n plus 1 only, like as he had done it over here. So this thing is a distance matrix. Okay, so if you basically know about the distance, so you can compute that how many steps that you need to go to that position, right? So he's giving a distance matrix that is G of size n. To be specific, there is B. So this is what over here it was mentioned. Okay, over here this is mentioned that store the number of steps in a distance matrix of size n into n plus 1. So till now we don't have any idea what this distance matrix is doing, but we'll just get to know about it. Okay, so xf is equal to power 2n minus 1. So that is basically taking that all the position has been visited. So remember one thing, whenever we are going for bit masking, so bit masking is basically like, let's say we have the bit, I mean the binary form of a element. So let's say it is like 1 0 1. Okay, now we have, this is of size 3. Now if we have an array, so let's say the array was given like you can consider a few elements and you can exclude a few elements. So this means that I'm going to consider the first element and the last element, and this element I am not going to consider. Okay, so this is what bit masking is, in case you guys, like, I don't know how many of you know about bit masking. So that is what he has done. So this is a kind of like taking the number of bits, okay, and then he's just going for the answer. So now let's go for the find. Okay, I think find will be over here. Yeah, so this is the position, this is the mask that it was given. Okay, so initially the mask is 0 because we are not going to consider that we have visited any channel, I mean any position. Okay, and the start position is 0 because we are starting from the position of the knight, that is AR of 0, and this is what, this is basically, I think this is stat. What the heck is stat? Okay, so like we'll get to know about stat, I guess. So what he is doing is, if mask is equal to xf, that is if xf is equal to the value of the mask when all positions are visited, that is xf that is given, that was given in the like he has made it 2 into n 2 to the power n minus 1, that is if all the position has been visited, so then only the value of the mask will be xf. In that case we can say that we have visited all the positions, so just return 0. Since it is like, I think it was something, it's recursive is like plus, so yeah, recursive is plus, so basically is returning 0 for that. Okay, so this is the base case, this is the base case, right? I hope this is clear right now. Now he's taking, if dp of mask of position of stat, what was the dp like? Okay, so he was just taking a 3D dp. Dude, now this is getting too complex. So it means that if he has memoized that, that is, he has gone to that position of mask position stat. So this is the memoization part. Okay, this is the memoization part. So he can just, he don't need to compute the recursive approach. Okay, so that is what he has done. Now if stat is equal to 0, so answer is equal to 0, and what he does is, he goes through all the elements of the pawns, because he is going from 1 to AR of size, that is, he is going to visit all the pawns, right, not the knight. So for that he takes the position of that thing, of that specific pawn, and he masks that pawn position and takes it with and 1. So what basically and 1 does is, it checks whether it's an even number or not. Okay, So basically, if we are going to mask it and checking it for the even thing, that is checking for the parity. We don't call even because even like will sound very much base to you. So we call the parity. So he's just checking for the parity, and since it is an AND, so only if the last element is 1, I mean the last position is 1, that is it is an odd number, so he's going to get the bit as 1, otherwise he's going to get the bit as 0. Okay, so that is going to give us the parity, that is mod 2. Basically this AND 1 is basically mod 2. Now if not bit, which means if the bit is even, okay, so if the bit is even, because we know that the last position is like, we know about the last position, so if the bit is even, he is masking that with the 2 to the power rp. Okay, because that position is marked right now. We know that we have visited that position. Let's say we have visited this position, so we are just masking this position in the bit mask. Okay, he is just masking this position. Clear? Now what is going to be the answer? Answer is going to be the maximum of whichever is going to be the answer, or we can find the g of position of I, okay, the present position, and then find from I to mask to 1 comma air of g, that is we are going to find recursively for the remaining positions, right? Now once we have masked it, so what he does is he is zoring it out. Why is he zoring it out? Because he knows that once he has masked it, he has to remove that. So even if you can't, like, even if you think that you don't want to zor it out, what you can do is you can initially take, like, instead of making this as mask directly, you can take a value of temporary mask and then you can ignore this. Okay, so this is what he does, and this one was for if the status, so stat is basically status. Okay, and I just realized it. So this is only if the status is 0, but if the status is 1, in that case he is doing a similar kind of approach. He is doing almost the same thing, apart from the fact that he is going for I mask 0 air of g. So it was I mask 1 air of g. So status means that if he is going to consider that specific position, or he is not going to consider that specific position, as I was telling you in this thing. Okay, so it is like whether he is going to consider that position or not consider that position. So that's what status tells us. Okay, he's not going to consider a specific. Okay, I'm perfectly visible and audible, I guess. So this is what he has done. So where was I? Yeah, this is what he has done. Like now he gets the DP of this thing done. But he has also done some few implementations before that. What is it? He is going to, one second, like this is void find, then what is this? This is int find. Exactly, that's the reason I was thinking that from where like he's taking this thing. Okay, so I get it now. So void find is basically he is doing the recursive approach to check what are the possible moves that he can perform with the perform with the knight. Okay, so you'll just get it. So we know one thing, that x of m. So if we are going for -2 -1, okay, just corresponding things. Okay, so if it is a -2 and -1, so it is a possible knight move. If it is a -2 and +1, it is also a possible knight move. Like what he means is basically, so since you know that a knight can move to +2 and then +1, or +2 and -1, plus +1 +2, -1 +2. So like this, like, right, the knight moves like this. So for all these 8 moves, so basically he has got 1, 2, 3, 4, 5, 6, 7, 8. So he has got 8 moves, right? So for every specific element, he is going to take this 8 moves. Okay, and this is the DP. We know that he can store, like he's storing a maximum possible value. I am not considering why he's taking that, because we can go for something more than this also. So what he does is he's taking the same thing almost. So now he's taking the map and the G, and considering his position, okay, this is basically the visited. Visit is basically the visited array of size 51 into 51. Why is it 51 into 51? Because we know that the size of the whole chessboard was 50 into 50, right? So and he's taking the one best index in so that it will be easier for him to like go for the problem. DP वाला part समझ नहीं आ रहा, बाकी moves वगैरह समझ गया. Okay, I'll explain the DP. So first let me just explain the whole code. Okay, what he has done. So visited array of size this thing. Okay, so where was I? So he's taking a tuple. So tuple is basically like, you know, like whenever we are going to go for like I'm so sorry, like it got disconnected. Why is the brightness so much, man? I don't know. Yeah, now I think I'm visible. But the brightness got too high. So just wait for a few minutes. Okay, so I'll just fix this thing. Fix this brightness thing. So now this thing is clear. Yeah, now I'm perfectly visible. The brightness is also fixed, and I feel like this is this is a proper setup that I was looking for. Okay, so let's get into this. समय cheater है, सौम्य cheater है, तो तुम कौन हो? So basically what happens is like push initial position inside the queue to start BFS. So he's pushing the initial position, that is x comma y, and then he's going for the BFS approach. Okay, so that is he's checking while q of size is greater than 0, that is he's pushing it to the queue, like you know what BFS is basically. So he's like popping it and I don't know. Okay, so basically he's popping it out, and for every possible condition he's checking what are the possible moves. Okay, check if x comma y is a required position. So first he is checking whether x comma y is a required position or not, and based on that he is checking for all the possible moves. That as I told you, there are 8 moves. So for every possible move he is checking what he can go from x to, and based on that he checks whether this specific position is well within that range or not, that is from till 50 or not. Okay, from 0 to 50 or not, since you know that the square was 50, so he can't get out of the chessboard. And if that position is not visited, then only he has to visit, he can visit it. So basically he visits it. So this is what this fine thing is. This fine thing is basically the recursive approach. Okay, recursive approach. The code may seem a little bit like difficult to understand, but like this code was kind of difficult. Okay, any code which is recursive, memoized, and let's say and using bit masking. So if you're at a beginner level, so I'll like tell you that just try to understand it, and if you don't understand it, it doesn't matter. Okay, it's okay if you don't understand it, it's completely normal. So as Soumya was telling me, so he wants to check the DP thing, right? He wants to clarify the DP. So basically see Soumya, what is happening over here. So DP is containing 3 positions, right? Mask, the position, and the stat. Okay, So what the stat tells us is, stat is telling us whether that position has been, that DP position has been visited or not. Okay, so this is what the stat position tells us. So if it is not visited, then we have not visited. It is like whether we have to consider that position or we don't have to consider that position. Okay, because we know that stat can be, I think it was stat of size 2. Okay, so over here he gave a size of 2 over here, and this was 16 because there are 15 positions, so he's taking 16 for better understanding. And this is 7000 because this is the number of steps that he can perform. This is the maximum thing that he can perform. Okay, because let's say you are at a position of a knight, and there are 51 into 51 squares, and there are total 15. So if you if you calculate, so I'll just calculate quickly. So if you calculate this, okay, my charge, just wait a minute, I'll just put my PC on charge. Okay, just wait for a minute. Okay, so now it's on charge. So if we go for 51 into 15, it is 765. Okay, and he is just taking 765 into 10. So I think that is for better approach. Okay, because he can go to 51 squares and then he has got 15. Oh, and he's also going to consider the status. So that is going to be 700 into 2. 756 into 2. So 756 into 2 is 1512. So basically, I think that's the reason he's taking 7000. 7000 is for safety. Okay, I can tell you this, that 7000 is for safety. As I told you that whenever you're going to have something like that, so it's basically you have to perform some safety operations. That is, let's say if you have to traverse till 1000, so it is always better that you take till 1001 or 1002, so that you won't get any memory limit. You don't get any array index out of bounds problem. Okay, basically you're just optimizing the runtime error. So this is the status which is telling us whether we have to consider that or not. That is, it can be of two values, either 0 or 1. Okay, it can be either 0 or 1, and for every specific 0 and 1 he has to store the DP. Mask is basically the position that he is considering. Okay, we know that the mask is initially 2 to the power n minus 1. So that is 2 to the power n minus 1 looks like this, some 1 1 1 dot 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 till 1. So all the elements are 1 for 2 to the power n minus 1. So basically for this he is going to consider all the positions. Okay, he is going to consider all the positions. Now if there is a 0 over here, so he is not going to consider this position. So this is what masking does. Okay, and this position is basically the position that we know. Position we know, right? So just tell me if it is clear now or not. Okay, position is position, man. I think I don't have to explain that. Position is the position of the pawns, or let's say the knights as well as the pawns. Is it clear right now? How do we identify if something would need bit mask or not? Okay, so see, I'll just give you a question. So this is whoever is watching this video. So I'll just tell you guys that this is not related to today's contest, but I'll just explain this, that how to understand whether bit mask is needed or not. So let's say you are given a array. Okay, now in this array you have to find what is the maximum XOR of all subsets. Of maximum XOR of any subset. Okay, so what is a subset? It means that you can take this element, then this element, then this element. So you can take any element randomly and you have to XOR it out, right? But let's say if I give you a different kind of thing, that is, you have to find the maximum subset, you have to find the maximum XOR of the subset as well as print that. Okay, as well as print that. So in that case, what you have to do is, let's say if I'm going to consider this position, this position, this position, and this position, so I'm going to get the maximum XOR, let's say. Okay, and I have to print this subset. So how am I going to find all the possible subsets, right? So whenever we are going to print something, so that means like you have to go for some constructive approaches. This is not constructive algorithm though. So the approach is kind of constructive. So whenever you're finding something like that, so what you have to do basically is you have to consider taking a binary string of this length, and since it is a binary string, so it will be consisting of 0 or 1. So if it is a 1, you'll just consider that element, and if it's a 0, you won't consider that element. So if you traverse from 0 to 2 to the power n minus 1, so 2 to the power n minus 1 is basically n number of ones, and 0 is basically n number of zeros. It can be more than n also, but for now we are going to consider n number of zeros. Okay, and this is n number of ones. So basically if you're taking any element from between this range, so you can find all the possible subsets, right? Now this is what bit masking is basically. Okay, so if this value is 1, you can go for that. If it is not 1, you can exclude that. So if we go for this approach, we can find out the XOR of all possible subsets, and we can also print that subset, print that possible subset, and print its possible XOR. Okay, so the problem could have been like, I'll just frame the question like this. Question is, find all the subsets of a find all the subsets of a array is the question. So let's say find all the subsets of an array is a question. So how many subsets are possible? There are total 2 to the power n subsets, and for every specific subset it is corresponding to a value of from 0 to 2 to the power n minus 1. I hope this is clear right now, Soumya, what bit masking is for and how to like get this bit masking thing. So anyways, people who have joined right now, it will be really helpful if you can subscribe my channel so that I get the motivation to make more videos. Please, it is a bit. Okay, thanks. That's good. So, and just subscribe my channel, like this video. If you want to join, you can join my Discord server. The link is over here. I've pinned it, okay? I'll also pin it in the comment section. You don't need to worry much about that. So that's it. So if any one of you have any doubt regarding any question from A to D, so just tell me, okay? Just tell me if you have any doubt regarding any question from A to D. So let's get in the hint also. Okay, use BFS to pre-process the minimum number of moves to reach one pawn from the other pawns. Clear. Consider the knight's original position as another pawn. Clear. Perfectly clear. Use DP with the bit mask to store the current pawns that have not been captured. Exactly. So this was bit mask. So if you want, you can go for some like similar problems. It was given that knight probability in chessboard. So you can check out these problems also. Okay, you can visit these problems if you want to practice more on this type of problems. टाइम हो तो भैया एक और क्वेश्चन करवा दो. लास्ट मंथ POTD में था. लास्ट मंथ POTD विच क्वेश्चन सौम्य? Strange printer. I'm just assuming that it's going to be like this. Strange printer. This question, right? The screen printer with following two special characters. The printer can only print a sequence of the same character each time. At each turn, the printer can print new characters starting from and ending at any place and will cover the original existing character. The minimum number of turns the printer needs to print it. Was it recursive? It's given as 100. I think this will take me time. Okay, this will take me time. But something that I can take out from this question is basically what you can do is you can find the first and the last position of every, you can find the first and last position first of the first character whichever is there. You can find the last position of that character and then print it and then check for the not getting job in IT sector. मेरे को कहाँ मिला है भाई, मेरे को कहाँ मिला है लीड कोड में 4 क्वेश्चन सॉल्व करने के बाद भी नहीं मिल रहा. The job market is too, what to say, it's I won't say anything bad about it, it's good, but as a fresher it's difficult. Yesterday I was giving a OA. Okay, so what was the package of that thing? I don't remember. The package was good. The package was good, normal, mediocre. The package, the problems were good, and there was a hard question in that. So just imagine that if the questions in a online OA are that hard, okay, so what is the future of CP? Because you know what, people usually do CP because they want to go for some the companies FANG. Okay, so Swami, I'll just explain this code later on. Okay, so first, since Prem is showing me so much of Prem right now, so I'll just tell you Prem which year how many questions do you solve. See, today I solved 3 questions, but I think I could have gone for the 4th one also because that was not that difficult. I usually try to solve I usually solve 3 problems for sure, and most of the time I also solve it's 50-50. I solve the fifth, solving the 4th problem is 50-50 for me. Okay, and I passed out I'm a pass out of 2024. Okay, this year I'm a pass out of this year. So at this moment I don't have any job. I missed a job opportunity, I missed a job opportunity thinking that I will get some better opportunity, and I think I fucked up. Okay, so basically what happens is whenever you're going to some Mang, okay, whenever you're going to Mang, I don't know whether I'm writing the spelling correct or not, which was initially FANG, now it is Mang. So college, can't reveal that, but I can reveal you one thing, that I was in a tier 3 college. Okay, I was in a tier 3 college. And this happened that since I was initially, my name was Peter Griffin Coach, and you know that I haven't revealed my face at that time. So there were some of my colleagues out there who used to follow my YouTube channel. And I remember one day that this happened, that one of my friend told me that, bro, you should start, how many questions you solved till now. See, it's if you consider I have 3 accounts, okay, Prem, I have got 3 accounts on Leetcode. And if you combine them, I have solved almost 600 questions. But at max in one account I have solved, I think, 400 somewhat questions. Okay, so it doesn't matter how many questions you have solved. I think till some extent it matters. If you have solved only 10 questions, so that is not good. But after you have solved 100 questions, so it should be the number of medium level questions you have solved, the number of easy level questions you have solved, and the number of hard level questions you have solved. That is what matters. Okay, because I feel that I don't solve Leetcode. Okay, I usually don't solve Leetcode except on Saturdays and Sundays, because I am busy giving some other contests. Okay. So as I was telling you, Prem, so if you're looking for Mang, so these companies, they have their own technologies. Okay, they have their own technologies. So if you know that Kubernetes, okay, Kubernetes. So what happened to Kubernetes is that it was a secret technology that was being used within Mang, within the Mang body, right? But it got revealed later on. So just imagine one thing. So before Kubernetes came into the market, so let's say they have a technology called X, or let's say XYZ, because X will remind you of something which you don't have. I am in my final year, average in coding. Do you think last year is enough to crack a job? More than enough. More than enough. I started coding in beginning of third year, but by end of third year, ऐसा हुआ था कि लाइक भैया लोग मेरे को बुला रहा था कि भाई आजा कोड कर दे, हेल्प कर दे ओए में, तो ऐसा होता था. ठीक है. So it's like that. Okay. So it's like if you work on it, 6 months is more than enough. I feel 6 months is more than enough. Like there's a video of mine called Computer Programming in 2024. You can watch that. So for better understanding of how to do it in the final year. Okay. So I've told over there like how to crack a thing, like basically you can crack any job. Okay. If it is based on DSA, you can crack it. So basically what happens is, let's say in a Mang there is a technology called XYZ which has not got into the market till now. Okay. So if it has not, if it is not into the market till now, so we know one thing, that we don't have any knowledge about that. So we can't include that in our tech stack. Now let's say whenever Mang is going to hire you, he's going to make you learn their own technologies. Okay. Which will be not available in any other place in the market. Okay. So let's say their own technology. So people usually like go for MERN stack. Okay, whenever they are going for development stuff, they usually go for MERN. Some people go for AIML, right? Some people go for AIML. Some people go for app development. And I think at this moment for app development, the best is Flutter. Okay, Flutter is best right now. Even I use Flutter. So if you tell me, so these are the things that I know just a little bit. Okay, I have a website on MERN. I have made up my final year project on app on Flutter. And AIML, I don't know much. AIML, I have got like almost near to zero knowledge about AIML. But since the app that I developed, so the backend of that was AIML. So basically I got a basic knowledge about what AIML is. So if you know these three things, okay, this is more than enough. Just knowing a little bit of these three things is more than enough to crack an interview. I mean to crack a normal job. But if you're going for Mang, so they know that these three things, this MERN, let's say they are not using MERN in their own tech stack only. They have their own kind of tech stack for full stack development. So they are not going to consider that whether how much you have furnished in this MERN, right? So for them, what matters basically is, market situation is at such extreme position. I have seen who knew average things getting jobs, and the guy who knew it. See, this is something that I can't tell because since I am also in the market right now, but I have seen people like who is not much furnished in their knowledge, they're getting jobs, and we are struggling. Okay, we are struggling. I don't know why it's so. See, no, there are jobs. I won't say that I have got no jobs at all. Like I have got no offer letters. I have got offer letters, but the amount that they are paying right now, it is okay. So basically, the amount that they are paying right now, it's like not enough, and they are not giving me the opportunity to stay in the state that I am preferring, right? So let's say if you are at Bangalore, okay, or let's say if you are at Noida or Pune. So the expenses in these states, or Mumbai, even Mumbai, the expenses in the states are like at a higher position, okay. But let's say if you are in Bhubaneswar or in the like eastern part of India, the expenses are kind of lower, okay. Even in Bihar also, the expenses are kind of lower. So basically, what happens is this expenses thing matters a lot for us. So at that position, like we have to like consider that we can't take this job offer right now because it's going to be like we are going to run in losses. But as an initial position, I'll prefer that no matter whatever job you're getting, just go into it so that you can gain the experience and you can go for some better stuff later on. So that doesn't matter. So as I was telling you, okay. So since these companies are looking at the XYZ data, I mean XYZ stack, so basically they are not going to check how much you're furnished in MERN, how much you're furnished in AIML, how much you're furnished in AIML, or how much you're furnished in app development. They are only going to check how much you know about the logic. And whenever you are talking about logic, what comes into mind is DSA, because DSA is something which tells us about our logic building. And there is also aptitude. Okay, there is also aptitude. Now if you're going to consider apti and DSA, so if we just combine them together, that makes us CP. Can you explain how the high value is chosen for binary search in second question, please? उसके लिए 4%. रेफरेंस के लिए हो रहा है. I don't know. Okay, I don't know because I think my network strength is not that good. So अगर तुम्हारे पास network strength होगा तो मेरे को मतलब ऐसे help कर देना, ठीक है? Because my network strength is not that good. And if you want to build a network strength, I think Bangalore is a very good place to build your network strength. Okay. So anyways, so he was telling me to solve the second question, right? So what was the second question? I just forgot. This was the third question, okay? Not this. This question, right? Okay, so what we're talking about, the high thing. Okay, so just let me check my submission also. Like this happens that whenever I am like coding something, so I just forget what I've coded, okay, at a later point. So when people ask me that how to do this, so most of the time it happens that I forget my code and I just go back to my code and just look into it. So it is like you're looking at high. Okay, so can you explain how the high value is chosen for minuses? Okay, so the high value, okay, yeah, I can explain it. See, let's say you have got X. Let's say you have got A and there are some elements over here. My friend said if he is not getting a job, he is ready to work in a BPO calls. 20K वाला जॉब तो मैं नहीं लूँगा भाई. नहीं, ऐसा ओवर कॉन्फिडेंस नहीं होना चाहिए. हो सकता है मतलब I have to take it, but yeah, it's kind of like shouldn't take it, man. Like if I'm getting a 20K job, so I'll just tell my parents that just wait for me, like just wait for 1 year. I'll prepare for my GATE exam. I'll go for some MTech in some good college, I guess. But in that case, what I have is like I have realized that whenever I'm doing CP, my GATE preparation doesn't get that amount of priority. And I'm like not that kind of guy who can sit on a book or like sit on to study for long hours, okay. But if you give me my laptop and I open like Leetcode code forces, I can sit on it for like hours and hours. I can work on it. But if you give me a book to study, it becomes difficult for me to study. So that's it. So yeah. So as he was telling me, the high thing, okay. So let's say you have this Z, okay. So if you're talking about this A, so this is going to be A plus D. Let's say A plus X, okay. No, not X. I want to consider like an alphabet which doesn't come. So let's say we are going to consider A plus theta. Okay. This is going to be A plus 2 theta. Right. So if we go for this, so the difference between these elements are going to be theta, right? Now for the highest possible value that we can have at a position, which will tell us that this position will be, we know by that thing what to say, by AP formula, it is going to be 1 minus n 1 plus a plus n minus 1 into theta, right? So basically if we know the value of z and a, so if we subtract z and a, it is going to be n minus 1 into theta, right? Now just for our better assumption, we can say one thing, that this value can be a little bit greater than this. So it will be in the range of n minus 1 to n, right? The value of this. But for now we are going to consider n minus 1 only. So if we go for this, so we know one thing, that theta is going to be z minus a by n minus 1, right? Now if this value is the minimum possible value of z, so this is obviously going to give me a better approach, right? So now is this clear? Who asked me? Abhilash, now is it clear? And Abhilash, if you are asking for that, the thing that I have done last year of college is so depressing, not getting jobs and no one is talking, no one to talk to because everyone is preparing for placement. मेरा तो अलग था भाई, मेरा कॉलेज लाइफ अलग था, ठीक है. Like I am in tier 3 college, I was in tier 3 college and my last year was like, last year में जो fun हुआ ना भाई, क्या ही बोले, मतलब full different level का fun हुआ भाई last year में. एंड उसी के वजह से आई जस्ट ब्लेम दैट फन, लाइक कि उसकी वजह से शायद प्लेसमेंट के लिए ज़्यादा प्रिपरेशन नहीं हो पाया, बट बेसिकली लास्ट ईयर एंजॉय किया भाई, विच इज़ ऑल्सो नेसेसरी. कॉलेज है भाई, कॉलेज एंजॉय कर लो, कॉलेज इज फॉर एंजॉइंग. Abhilash, just tell me if it is clear or not. And anyways, as I was telling you, Abhilash, if you are talking about 2 into 10 to the power 9, that thing, okay, this is because I know that, let's say we have got only 2 elements. One is 0 and the other is 10 to the power 9. Because we know that this is the maximum and minimum value, right? Is it so? Is it so? Just let me check also. ऐसा बोल रहा हूँ फिर बाद में पता चलेगा नो ऐसा नहीं है. या दिस इज द मैक्सिमम मिनिमम वैल्यू. ओके, एंड व्हाट इज द मैक्सिमम मिनिमम वैल्यू ऑफ डी? इट इज ऑल्सो फ्रॉम 0 to 10 to the power 9. So since I am going to consider 10 to the power 9 only, okay, I am going to consider 10 to the power 9 for the value of d. Microsoft की ओपनिंग है. सौम्य, आर यू ऑन माय डिस्कॉर्ड चैनल? If you are on my Discord channel, just give me the link also, okay? Microsoft में कोई जान पहचान का है नहीं अभी. एक दीदी थी जान पहचान को माइक्रोसॉफ्ट में, बट वो तो अभी गूगल में चली गई. मिल गया बेटा अपॉर्चुनिटी, चली गई. Okay. So basically what happens is, like, let's say if you have got, yeah, so this is also 10 to the power 9 and this is also 10 to the power 9, right? So what you can do is you can add this to over here, which makes it 2 into 10 to the power 9, and the difference from this to this value is maximized to be 2 into 10 to the power 9. Okay, so this is the reason why I have taken 2 into 10 to the power 9, because this calculation is too complex for us to compute, but this also satisfies. Okay, so just to take a numerical approach, we can go for this, and if you want to go for the formulatic approach, you can go for this. Okay, I hope this is clear. Anyone else, any other problem, just tell me. Just tell me if there's any other problem. I also need to make the thing, okay. I also need to make the thumbnail. So people who think that coding is not easy, okay, coding is difficult. Coding is not difficult, anyways. Because I'm going to show you something. Okay, I'm going to show you something. Just देखो, ठीक है? Just see it. So I usually code on my phone. So I used to code on my phone, Leetcode. Initially I used to code on my phone because ऐसा होता था कि सुबह मतलब if you're waking up at around 8, so it was kind of lethargic for me to open my laptop and like go on Leetcode. So I used to like wake up early in the morning on Sunday and just open my phone. Like at that time when I was using my phone for coding, so at that time it was like uh, जितना मतलब क्वेश्चन बनता था I would upload it on YouTube, and after that I will just go to sleep back again. If I feel that one question is kind of difficult and I don't want to stress my brain out on it, so I'll just go to sleep. Like I am making this video right now, I am going live right now, but after like I stop this live I'll be going to sleep. Okay, because कल रात को काफ़ी लेट सोया मैं. And this is good to see that this live stream was well interactive. Okay, this is exactly what I mean when I'm talking ki I need some good audience. Okay, so this actually makes me enthusiastic that I should continue making more videos. Okay, because if I find that there are no much people, okay, so it becomes kind of difficult. So anyways, just let me check how many, like, is there any contest tonight? Is there any contest tonight? So this is GFG contest. Okay, this is GFG contest. So guys, just do one thing. I think GFG like posts their this GFG contest. I don't know. I use this code clock thing. Okay, this code clock. This is not a paid promotion. Code clock. If you can pay me, just pay me. It's okay. But this code clock, this app is very good. Okay. So if you guys have no problem regarding this, so I'll just end my video. Okay, so just you can do streams with virtual contest showing how you think while solving. See, if I stream using virtual contest ना, तो क्या होता है मेरा? I can't like think when I'm streaming. Okay, it becomes difficult for me to think while I'm streaming, because if I'm thinking on a problem, like जब मैं stream कर रहा हूँ, like at this moment, you can see one thing that I'm talking a lot, right? So that you guys are kind of like energized, that you guys think that I am like into the contest. But if I'm streaming live, so throughout these 2 hours I don't talk. Like if you like know me personally, I don't talk much. Okay, I'm a very kind of let's say kind of introvert. Okay, I'm a kind of introvert, so I don't talk much. So technically I can't stream virtual contests. So that's it. So if you guys have no problem, I'll just end this video. Just tell me if you guys have any problem or not. Okay, just be quick. Okay, bye guys. Thank you guys for joining. So I'll just end this video. Okay.